So this whole 3 sections of chapter 5, 5.1 to 5.3, it's all about solving inequalities and also graphing the inequality on a number line. So to graph an inequality on a number line, we must understand if it's greater than or less than symbol, right? The best way to do this is to think of a hungry Pac-Man. It always wants to eat the greater value. So when we compare the 4 and the 5, the Pac-Man's hungry. Obviously, it's going to want to eat the greater value 5. That's why it's opening up to the 5. When you compare -8 and -9, the Pac-Man's hungry. It wants to eat the greater value, so that's why it's opening up to the -8. Now, I know some of you are thinking, wait a minute, isn't 9 bigger than 8? Okay, that's true. 9 is bigger than 8, but when you think about the number line itself, whatever's on the left side or further left is going to be less. Whatever's on further right is going to be greater. Let me explain this a little. This first one right here, the 4 and the 5, when we compare it, down here we have a number line, and it says, let's plot 4 and 5. And anything on the left side will be less. Anything on the right side will be greater. That's why I put these notes right here on the number line. So let's plot the 4 and the 5. So get your pencil right now and put a dot on 4. Put a dot on 5. And you could clearly see that 5 is on the left side or the right side of 4. It's on the right. So 5 is greater than 4. Or you could look at it in terms of 4. 4 is on the left side of 5. So 4 is less than 5. Now I know you're thinking, this is ridiculous. I already know that 5 is bigger than 4. Right? But look at the next one. Let's plot -8 and -9. So let's put a dot on -8. Let's put a dot on -9. And now it becomes a little more clear which one's bigger, which one's greater. The -8. Now, why is that? Because -8 is on the right and -9 is on the left. So -9 must be less, -8 must be greater. Make sense? Yeah. Easy peasy. We already know that over here, the positive numbers, 1, 2, 3, 4. So anything that's closer to the positives will be greater than anything that's further away. So -8 is greater than -9. Let's move on down here. Let's practice. I want to hit pause. I want you guys to fill in the appropriate inequality symbols, either a less than symbol or a greater than symbol between the 8 and the 6, the -8 and the -6, and the -9 and the -99. Go for it. So there are our answers. Again, the Pac-Man always wants to eat the bigger value. 8's bigger, -6 is bigger because it's closer to the positives. -9 is bigger because it's closer to the positives. So that's how we get those inequalities. Let's continue here with our notes. When we graph an inequality such as x is greater than 2, we're really saying that we want to represent all the numbers that are greater than 2. So give me a number that's greater than 2, anybody? 4, 3, 10, 1,000. 2.5, 2.01, right? So it could be 5, that's greater than 3, 4 is greater than 3, 3 is greater than 3, it could be 1,000 greater than 3, it could be 2.5, it could be 2.1, it could be 2.0001. I mean, you could technically get super close, right? You could get super close, but not actually touch the 2. And that's why we use an open dot, because you cannot actually include 2. I hope that makes sense. If we're graphing x is greater than 2, you're talking about all the numbers that are greater than 2, and 2 is not greater than 2. 2 is equal to 2. Make sense? Yeah. Okay. So that's why it has to be an open dot and going that way. Okay. X is greater than 2. You got me confused. I got you confused. Yeah. Okay. So whenever it says just greater than, it's going to be an open dot. Whenever it's a greater than or equal to, it's going to be a solid dot. Because the or equal to allows the 2 to be equal to 2.
No, but what you said about x equals 2, that's what got me really confused.
Okay. So give me a number that will make it a true statement right here on this x. Could it be a 5? Yeah. Could it be a 7? Could it be 1,000? Could it be -23? No. Can't be -23. Could it be 0? No. Can't be, because 0 is not greater than 2. Could x be 2? Can't be 2, right? So that's why it's an open dot, okay? It can't be 0. It can't be negative numbers. It can't be -4. It can't be 1. it cannot even be 2 because 2 is not greater than 2. Now, down here, I do have one that has the or equal to, right? It says, now, if we had a graph x is greater than or equal to 2, then you could include the value 2. So it would be a solid dot. So any number that's greater than or equal to 2, it could be 3, that's greater than 2. It could be 5, it could be 6. It could even be 2 because it says greater than or equal to. So that includes the number 2. So here's the important part of today's notes. If there's and that's what we're about to go on the notes right here. If your inequality has a solid line underneath it, that means or equal to. It'll be a solid dot. So once again, if your inequality has a solid line underneath it, it's going to be a solid dot. If it does not have a solid line underneath it, it's not going to be a solid dot. It's going to be an open dot. And fun fact number 2 of the day, it says if x is less than, then it's going to go to the left. If x is greater than, it's going to go to the right. Simple. Okay? So let's practice right here. Number 1, it says x is less than 6. It's going to be an open dot at 6 because it does not have a solid line underneath it. Like this guy is going to be a solid dot. This one's going to be a solid dot. This one's going to be an open dot. When it has a solid line underneath it, it's going to be a solid dot. When it does not have the solid line underneath it, it's going to be an open dot. So we already know that it's an open dot. That's good. Now, how about Jezreel? What would the which way is it going to be pointing? To the left or to the right?
To the right.
Okay, now what does it say right here? X is what compared to 6? X is
Great.
okay. Now
Less than.
think about the Pac-Man. The Pac-Man wants to eat the 6, so X is definitely less than 6, right? So if X is less than 6, and I want to represent my X's on this graph, which way is less than? To the left or to the right?
Left.
To the left. So I'm going to go left. Put an arrow right there. Jesus. Number 2. Is that going to be a solid dot or an open dot? Solid dot. Okay, so let's put a solid dot at 4. And Nicole, is this going to be going to the left or to the right? Or how about this? Even before that, Nicole, let me ask you this. Which one's bigger, the X or the 4? The X, because the Pac-Man wants to eat the X. Okay? So this really says X is greater than or equal to 4. Which way is greater than? To the left or to the right? To the left or to the right? Greater than is to the right. So let's put that arrow going that way. Number 3, is it going to be a solid dot or an open dot? Solid dot. Okay, so let's go to -7 and let's put a solid dot right here. And from that dot, am I going to be going to the left or to the right? Katie, what do you think? To the left. Why is that? Because this says X is less than -7. See how it's opening up to the -7? That means that -7 is greater. It's hungry. It wants to eat the -7. Now, you want to talk about X's here. You want to represent X's, so X must be smaller. If the Pac-Man's ignoring the X, that means that X is less than. And less than is always to the left. Less than is always to the left. Jumping back over here to the beginning, anything on the left side or going to the left is going to be less. Anything on the right side is going to be greater. So let's go back to that last one. Now right here, is it going to be an open dot at 3 or a closed dot at 3?
Open.
Open dot, okay? So Ezequiel, am I going to be going to the left or to the right? To the right, right? Now some people get confused right there because they think, wait, that's a less than symbol. It should be going to the left. But that's not true. You always want to be able to have your X on the left side and your number on the right side, okay? Right side. I'm confusing myself now. So I would actually take this inequality and I would rewrite it with the X on the left and the 3 on the right. And of course, if it's opening up to the X, my inequality has to continue opening up to the X. So let me fill it in that way. So this is the new and improved inequality, and now it's ready to graph. That's saying x is greater than 3, and greater than is to the right. You got it? So now that we have reviewed graphing inequalities, when do you get an open dot? When you don't have a solid line underneath it. When is it a closed dot? When you have a solid line underneath it. Now that I know how to graph that, let's go to solving inequalities. And solving inequalities is almost exactly the same as solving equations. The only difference is if you multiply or divide by a negative, you must change the inequality symbol. Now, I should say if you multiply or divide by a negative on your last step, I guess that's better to say that, on your last step. Or if you multiply the entire equation, both sides, or the entire inequality, both sides by a negative, that's when it flips. So let's look at number 1. Let's pretend it's an equation, and let's solve it. You want to get x by itself, so you get rid of that minus 4 by doing the opposite, plus 4, just like you said. Add 4 to both sides. We're going to rewrite this thing. It's going to be 3x greater than 12. Now for my final step, Damien, what do we do? Divide by 3, divide by 3, and I will have x. I have 4. Now, Gustavo, what would your, or what am I trying to say here? Do I keep the sign or do I flip the sign or do I change the sign? Keep it. Why? Because you did not divide by a negative. It's positive 3, so we're good. You keep it. That's our final answer right there. Now, right here on this worksheet or on this page of notes, I didn't have enough space to graph, but you should be able to, if I asked you to graph, put the 4 right in the middle and put a bigger number, put some smaller numbers, and this would be an open dot at 4, and it's greater than 4. X is greater than 4, so I'd be going to the right. So just always remember that you could be able to graph any answer that you get to any inequality. Let's move on to number 2. So number 2, Alec, what do we do here? What's our first step?
Get rid of the fraction.
Get rid of the fraction. How do I do that?
Multiply
Every single term by the denominator 3. Okay. So there's only 2 terms, so we multiply both of those terms by 3. The 3 is on top. 3 over 3 is 1. It cancels out. So I really do have a 2x left over. I have the inequality that comes down. And negative 4 times 3 is negative 12. Now notice that I multiplied both sides by 3. So the inequality did not change. If that would have been a negative 3 down here, and I multiply by negative 3 and multiply by negative 3, then I'd have to flip the inequality symbol. So right here, it's multiplying by 3, not negative 3, so I don't change the inequality symbol. So my final step is going to be, Adolfo, to do what? Divide by 2, divide by 2. X is less than or equal to negative 6. Once again, you do not flip it because you did not divide by a negative 2. You only divided by 2. I'm not going to graph that one. Let's just move on. Number 3. This is where you're going to have to change the sign. Paulina, what do I do? Divide by negative 2. Thank you. That'll cancel it out. What you do to one side, you do to the other side. X is all by itself. 10 divided by negative 2 is negative 5. Here's my answer, but what do I do to that inequality symbol? Change it. So it's going to become a less than or equal to. Why do we change it here? Because we divided by a negative. When you divide or multiply by a negative, on that last step, that's when your inequality changes. Jumping to number 4. Viviana, help us out. What would you do if this were an equation and you wanted to solve it? Distribute, that's right. So on the left side, there's just the nice, beautiful number 17. On the right side, there's a lot of stuff going on. We need to simplify all this stuff. So like you said, let's distribute first. So I'm going to distribute this positive 2. Positive 2 times x, that's 2x. Positive 2 times negative 3 is negative 6. And let me bring down the rest. I'm going to put the plus sign in front of the 2x because that was a positive 2x. The 3 comes down and the minus x comes down. So I've distributed, but now I could do what, Nayla? What do you do after distributing to simplify? So when I do combine the positive 2x with the negative x. Nayla, what do I get? 2x, take away 1x, what's that in your head? 1x, right? So we're going to have 1x. You don't even need to put the 1. And then when we do 3 minus 6 in our heads, what do we get, Nayla? Negative 3. Okay, so this is the entire right side of the inequality. I've simplified all this junk up here. It became 1x minus 3. And like I said, you don't even need the 1. I'm going to erase the 1. Let me bring down the rest. I have the inequality. I'm just going to bring it down. I have the 17. I almost have x by itself. I need to do one more step. And Gabriel, what would that step be?
Add 3.
Add 3 to both sides. Plus 3 here. Plus 3 over here. You're going to have 20 is less than x. And that's your correct answer. But what could we do, Leslie, to make this answer look a little bit better? Flip it around, right? Put the x on the left side and put the 20 on the right side. Now, if you're confused when you flip it, I mean, this is your right answer. It's opening up to the x. So down here, it has to still open up to the x. Okay? It has to still open up to the x. So there's your final best answer right there. X is greater than 20. Let's move on. Jose. Let's look at number 5. What do I do on number 5, Jose? To start getting W by itself. Times by 2. Okay, so let's multiply both sides by 2. Put the 2 up here. Put the 2 over here. That way the 2's cancel. And Jose, what's my new inequality going to be? Less than negative 16. Okay, so the inequality did not change because I didn't multiply by a negative. I multiplied by 2. So I still need to get the W by itself. Michelle, what do I do? Subtract 3. Subtract 3. I'm going to end up with W is less than... Monse, help me out here. W is less than what? Negative 19. All right. Okay, so there's our answer. Let's move on to the last one. Okay, so there's many roads to the same place. Alexa says multiply everything by 3 to get rid of the fraction. You could do that, or you could also get rid of this 1 right from the start by adding 1 and adding 1. It's totally up to you. Okay, so let's go with what Alexa said. Multiply everything by 3 times 3 times 3 times 3. But like I said, you could have said plus 1 here and plus 1 over here. That becomes a 14, and the whole thing actually becomes smaller. But let's stick with the multiplying by 3 because Alexa wants to. Okay, so we have the 3's that cancel. We have 3 times 13, which is 39. The inequality doesn't change because I didn't multiply by a negative. And we have 2a left over. And we also have 1 times 3, which is 3. So 39 is greater than 2a minus 3. Jethro, what do I do next? Add 3 on each side. Thank you very much. So I'm going to end up with 42 is greater than 2a. And so for my final step, Isabel, what would I do? Divide by 2. All right, divide by 2. Divide by 2. A less than 21. Notice that I read it from right to left. A is less than 21. If you read it this way, it's going to say 21 is greater than A. So the better answer would be to write it with your A on the left side, your 21 on the right side. And which way does it open up, Kayla? Does it open up to the left or to the right? Does it open up to the A or to the 21? To the 21. If it opened up to the 21 here, then it has to continue opening up to the 21 over there. Ladies and gentlemen, in a nutshell, this is it. This is all 3 sections. It's all exactly the same. You're just solving inequalities exactly the same as you solve equations. The only difference is if you multiply or divide by a negative, you have to flip that inequality symbol. And also, I might ask you to graph your answers, solid dot, open dot, depending on if you have the or equal to, and left is less than, great is greater than.